No, so now I will note down the points, the concepts. Sorry, the first concept that P is association rule mining. The or you can say association rule mapping. Both are mean the same thing. Then we will see the Hadoop and the MapReduce paradigm. The MapReduce paradigm. Then we will see the Hadoop architecture. These are the basics. So first we will see what is association rule mining. Association rule mining uh, displays relations that are not easily visible in a MySQL or a NoSQL database. So suppose I have a grocery store. In that I suppose I have a grocery store. In that I sell. So I have a store. I sell tea, make coffee, and you can say milk, tea, coffee, and suppose alcohol. So no, not alcohol. Cold drink. So now what is happening is I have a training set. In order to training set. So training set is a collection of, so there is big, suppose I have 2 lakh customers. I need to uh, uncover the relationship of the data, whether it is the whether it is structured or not. Normal scale or no scale operations may take a huge amount of time to uh, to gain the relationships between different data values. So we develop machine learning, data mining, data mining algorithm uh, for the above. So now we just go through it again. First concept is association rule mining, then it is MapReduce paradigm, then Hadoop architecture. So this is the example of a train tuple one. And here is tuple two. In the tuple 2, I will just write tea and coffee. And in the third tuple, the third transaction, I will write only cold drink. Here you can see that in each tuple, the number of columns are different. So this is not a structured relational database. This is unstructured data. So you can see that Hadoop, Hadoop architecture works on structure as well as unstructured data. It uses supervised learning plus plus some heuristics. Let me say this one. I will save it in. Well, now let us again see in this the concept civil learn association or mining MapReduce paradigm Hadoop architecture. So what is a tuple? Tuple is a kind of row or a transaction data that is sent to the Hadoop node. Tuples are separated by some delimiters. If you want, you can write space as a delimiter. If you want to use the .csv file, you can use comma as delimiter. So I will write comma like this. There is no end. Sorry, end is not there in this is for CSV file. But I am not using CSV files. I am just uh, using the space as a delimiter. So you can have up to the more the data, the more scalable is the Hadoop architecture. We will go to that how it is super scalable. So now here this is unstructured data because the number of columns in each table are different. So this is unstructured data, but Hadoop works also on structured data. If I in every row I had four columns, then also it would have worked. So if you can work on my MySQL or relational database as well. So it uses supervised learning because uh, the some data has to be required. That data is called training data. What is training? The training data is a set of rows that is used for each transaction, and it is used for testing your Hadoop code on your local machine. So suppose I have given this tuple one, tuple two, tuple three. This is our training data. So now I will just give an example of training data. This is my first row. This is my second row, and this is my third row. So this training data is stored in a file, and it is using Java file handling. We import the training data. So this is our raw input data. So suppose if the training data contains 1,000 transactions, 4,000 transactions, So, so it is impossible to uh, map the association rule using a single node. So that what Hadoop does is it uses its HDFS Hadoop distributed file system to send the training data in equal size chunks to each of the slave nodes. So the slave nodes get the in slave nodes there are the data nodes. So what happens is it stores it in the data. Then the reducer function is there. It will analyze the data and produce some output. So now this is all about the training data. And the customer transactions can be 2 lakh also. It can scale. So suppose I need to uncover some relations. Like I want to find out that whenever he has bought tea, has he bought what is the probability which he will buy tea? So that is an association rule. So now, yeah. So if you are not using association rule, if you are using normal SQL or no SQL, it may take a huge amount of time to gain relationships between the different values because we will have to have joins and inner queries, sub queries, and then we will have to have multiple tables for small things for normalization. So SQL or non-SQL are not suitable for larger transactions that want to uncover some relationships. That's why for data mining purpose we have used Hadoop. One more thing that I want to tell you is what is the difference between machine learning and data mining. Data mining is takes as input a database. It may be relational, it may be structured, it may be document based, it may be unstructured, and it provides the provides the analytical understanding of the data. But machine learning is a thing that it works like a robot. So you give it some command and it will learn. It will respond to it. So now the data mining algorithm we are developing is the a priori algorithm. Let us again revise it. So we have three tuples. Inside that, it is every line is space delimited. Then it Hadoop architecture works on structured as well as unstructured data. Like if the number of columns are different and some columns are blank, so yeah, it works on structured data as well as unstructured data. It uses supervised learning, so it has to have some input patterns and some heuristics. So one example of heuristics is for the Android version. So suppose I need to find out that how many person who have Lollipop installed also have Marshmallow installed in another device. So for that we will just alphabetically search it. So Jelly Bean. So after J comes KitKat. So it will search for KitKat. So what will happen is if KitKat is there with Jelly Bean, then the most probable is after that is Lollipop cake. So uh, Jelly Bean, KitKat, and lollipops. So these are the heuristics. Heuristics means estimates used for analyzing the data. So what happens in the association rule mining uh, algorithm? Before that, we will see on what is training data. Training data is the data again of transactions. So yeah, so now that so we are covered the basics. Now we will see what is associate four terms. First is the association rule. Second is the support. Then the confidence rate. And then is the support count. So we go one by one. Association rule. Sorry, it states that whenever uh, item X is present in the transaction, then Y occurs in the transaction with X X% probability. So suppose I have in X I have milk and in Y I have tea. So the association rule states that whenever the item milk is present in the transaction, then tea occurs in the transaction with a certain amount of probability. So if the probability is 80%, and that probability is 80%, but our confidence rate is 85%, then it will be rejected. So what is support? Support is a count that uh, results in the number of occurrences of both milk and tea together or individual. So what is the meaning of this? So support means suppose I have let us go to that training data. This is our training data. So now in training data you can see here support is counted as the individual number of occurrences of both milk and tea together. So this is milk. This is uh, this is milk and tea. So milk and tea is there, but what is happening here is there is no other milk, only tea is there. So the output of this will be 2. So the it, so see here in this training data, milk has come once in one transaction and tea has come once in one transaction. So here we will just type 3. The support count will be X union Y, that is 3. So what is the confidence rate? Confidence rate is the ratio of both the occurrences, sorry, not both, all the occurrences. The confidence rate is the ratio of all the occurrences of the milk and tea together. This is the confidence rate. So we have understood as an association rule, support, confidence rate, and support count. So we can say confidence rate is equal to X industry Y is equal to 1. First row of training data. So now sorry, and confidence rate is y when x. Yeah, so confidence is the probability that um, when t is there, when milk is there. So t is there when milk is there is only one. So that is confidence rate. Milk and tea when I first heard about this line when tea is present. So now this is the uh, concept. So now we will come to the uh, Hadoop components. So Hadoop has a lot of components. Hadoop first component is HDFS. In HDFS, a file system is distributed over various nodes. So suppose if I have 4,000 lines of data in 10 times. So if I have 400 of 4,000 columns of data, so 4,000 blocks of data have to be processed. So what it does it to again parallelism. So here we were in the mapper function. So it project and the reducer function takes into account the count and then merges the respective count of that item set by just adding and sorting. That is combining step. So now we have just seen the basics. So now you will see the architecture of Hadoop. Hadoop architecture. So in Hadoop architecture, you can see that there is a single master node and managing a number of slaves. And each master node consists of a job tracker, task tracker, name node, and return node. So if a machine fails, Hadoop continues to operate the cluster by shifting the work to other machines. So if a machine fails, Hadoop continues to operate the cluster by shifting the work to remaining machines. So that is what is called as fault tolerance. So fault tolerance is overcome using you can say using a replica. So every master or slave node has a replica and the replica can be more than one, more than two. So yeah, so we have just the components. First we'll say one master and slaves. The master manages the number of slaves. The master node consists of a job tracker, task tracker, name node, data node. Let me guess. So each master node consists of a name node. Name node assigns the task to the job tracker. The job tracker monitors the status of the job and the metadata of the job, and the metadata of the data node received from the name node. It has that data, so it generates a request to each task. So one job has many tasks, and one name node has many data nodes. So the thing is that it is possible to have only data node, data storing nodes, or processor storing node, but it uh, is optional. So now we will see how the functioning of the architecture on MapReduce works. Hadoop on MapReduce. So our main topic is this Hadoop on MapReduce. How does Hadoop on MapReduce work? So Hadoop on MapReduce has a set of tasks. So Hadoop divides 4,000 lines into suppose 10 parts of each of 400. Then the data is shuffled. So after shuffling of the the data is given to the mapper. The mapper then performs the sorting function on each line. Suppose I want each line to be sorted. So the each uh, mapper function just shows the count, sorts the line words. But after that, the key is suppose I have name. So name is the key. Gaurav is the key, and the list of marks he has scored in all the subjects is the value. But it should be sorted. So the mapper has sorted it, and it has given the key is Gaurav, and and also shuffle. I forgot, right? So the first step it is done as taken even size inputs. Then next it has taken after taking input it has processed the data. Then after processing the data, it has sorted the data. After sorting the data, it sends key value pairs like Gaurav, Gaurav, and then 2469. So this is sorted. Gaurav is a key and 1484 is the sorted. So that is whenever a mapper hashes each bin whenever mapper hashes converts it into a hash, each you can say um, uh, bin each mapper writes to the output to the disk. So it is returned to the HDFS and to the disk also. So like you can say the key can be any type and the value can be also any type. So that was our Hadoop on MapReduce. Now I will write I will open a new file. So now before that we will understand what is pruning and merging. So suppose I have a data set dog, cat, dog, horse, kitten, horse, pig, monkey. So these are my our training data. So now it has three transactions. So now we are going to study now a priori algorithm. So a priori algorithm starts from the bottom up approach. So it starts from a thing. Suppose my confidence percentage is 80. So what will happen is a priori will first take all the the single elements milk. So for milk it will store in you can say milk will it will store in dog and cat. This will be done in the first mapper. So after that mapping, I will search for the next one. So this is first mapper. So second one will be uh, dog. So in dog there are you can see dog. The first is milk cat and second is milk cat, and then it will go to the next one, that is dog horse. So again dog in dog horse is there. So this is done by the second mapper. So now after that have a I will search for cat. So in that cat there is only one row, so milk and dog are associated with cat. So this is done by the first mapper. Then it will search for kitten. Kitten has only one, so horse, pig, and monkey. So this is done by the second map. And then we have done milk, dog, cat, kitten, horse. Now horse is remaining, pig is remaining, monkey is remaining. So horse is remaining, pig is remaining, then monkey is remaining. So horse, pig and monkey. So pig and monkey are there only in uh, kitten, but horse is in dog and kitten, pig, monkey. This is again done by the first map. So now for pig and monkey it is same. So here kitten, horse. So now kitten, horse and monkey. So this is then again I will just do now this again has been done. So we have used you can say four mappers and four mappers four sorry two mappers four in each mapper has run four times. So confidence is 80%. So now we will see in the next step I want to check if milk and dog are there. So milk and dog. See the first two rows I will combine. I will go from bottom to up. So milk and dog is there in one. So I will prune all the other steps. So I will prune the remaining tuples.